Hi, welcome to week 2, lesson 1 of our database development design series. This lecture is called First Things to Consider. This video series is set up to be ancillary material for my course I'm teaching on database development design at a local college. Now, with all my videos, I do make sure I have a full write-up on my website, analyticsforall.org. I'll put a link down in there, and this will follow along with the slide deck we're going to go over here in this lesson. So let's just get right to it, get started here. We're going to start off with some basic terminology here for database design, database development. We're going to start from the biggest in moving in. So we're going to start with a database. That's a collection of structured tables designed to store data. So this blue sphere in the back, that's representing our database here. And then tables, that is the object that actually holds data. And you can see we're working with this relational databases here, so think SQL, not so much as unstructured databases. So we're definitely working in what you'd call tabular form, so you think a lot like an Excel file. So sometimes it's easy to start this off, to start to think about databases as just a collection of Excel files being stored. It's not the correct way it's doing it, but it's a good visualization, I think, for people to start with. Now we have, up top of the file, we have columns, and you notice they're being called fields here. It's a term you're going to hear. I don't think it's the most common term. I personally think column is probably what you're going to hear most people say. You can also hear attribute could be used. But, for this lesson, we're going to call it, I'll probably end up calling it a column, honestly. But here it is, a fields, just so we know that's what it is. Another name for column is field. And rows are called records. So you got rows here, and they are all our records. Now, I know this course is focused on using Microsoft Access as our database, but and I'll be doing some videos on that too, but I really want to kind of introduce what is probably a more realistic database you're going to see out there. Here's a very popular one called MySQL, and I like it, and I recommend people to learn it because, number one, it's free. Number two, it works with any system, whether you're using Mac, Linux, or Windows like I use. It works, and it's really simple to install, and it doesn't take up a lot of space on your system. But I want you to know this MySQL, and this is the MySQL Workbench, which is just a GUI that lets me interact with the database system, is not a database. It is a database management system. So DBMS, it's a phrase you're going to hear a lot, database management system. So okay. And because we have a relational database, again, relational databases are these structured tabular databases. And we'll get into what the relation is based on how the tables interact with each other. Tables are related together in a relational database, and we'll get into more of that later. But so you're going to also hear the phrase RDBMS, which translates simply into relational. If I could spell correctly, that would be awesome. Relational Database Management System. So that's what this is. So this is an RDBS. So again, MySQL, SQL Server, Teradata, Oracle, they're not databases. They're database management systems. The databases are what are inside here. Right down here, these are all the databases. A couple of them I've created here. A couple came with the system. Like this sys one is actually managed. It helps manage the actual workings of the DBMS. Tracks things like users, that kind of stuff. But each one of these is a database, and you can go inside a database and you can look and you see you have things like tables, and the tables have things like columns, so you can see. And if you actually search one, like I've got this one right here, and this is SQL here. This language I got right here is SQL. So what we're doing is I'm saying select star. That stands for, it's a wildcard. It means I want everything from the first part, database design, is the actual name of the database, and dot grades. Okay? So select star from data dev design dot grades, and if I run this, you're going to get the results down here. And as you can see, this looks very much like an Excel type of file. It's, got columns or fields, and we've also got rows. Okay? So this is what the databases you're going to see more in the real world. We'll get into Access a little bit later. So I wanted you to see this. And every once in a while I'm going to pop up and show you how it works within regular databases. Let's move on with the slides. See, at a very high level, all we want is a database that's going to store our data, bring the data in. allow us to interact with the data, ask questions of it, and get our data back out in the form of report and export wherever we need. If we can't do that, we don't design our databases correctly. So we're going to look at, why you don't just want to stick data in a table. Why we want to try to think about how we're going to put those tables together. So let's just a quick, and this is again very high level. So we're going to go in. Let's start with an example situation where a kindergarten teacher puts out a sign-up sheet during back to school that allows parents to donate various supplies. And you can see you have parents and you have donations, and you probably can't read this because my handwriting is atrocious. That's why I went to get my doctorate, so I can just get away with having bad handwriting. But in this situation, so the kindergarten teacher takes that list and puts it into an Excel file here on the left here. And you see they just put the donations all in one box, separate them by commas. So you can see Greg Carter's bringing crayons and tissues. Allison's bringing tissues and markers. And they decide, hey, I'm going to stick this into a database table. So they go over and they create this database table. And instead of using the commas, they decide, hey, I'm going to make columns for each of the donations. Now let's look at this table real fast before we get to the next slides and say, okay, what things can you think possibly could be problematic here? Well, the first thing that jumps out at me is what happens if Juan here decides to bring something else. Let's say he wants to give out crayons too. Well, now we'd have to go through and actually put a new column in that table. And with a database, it's not as simple as just adding another column in an Excel file, because sometimes, because again, it's relational databases. This table is going to interact with other tables. So other tables are expecting this table to have only 3 donation tabs. If you add another one, that could be a problem. Another issue is that this is what is known as one directional, meaning if you asked me, what did Mary Martin bring? I can look and quickly say, hey, she brought rulers. Or if you ask me what Greg Carter brought, I can really quick look and say, hey, crayons and tissues. If you ask me who brought tissues, I have to search across 3 different columns, which may not seem like much, but I want you to imagine, like I work for Verizon. We have tables with hundreds of billions of records. And if I got to search across 3 different columns, that's going to make my search take that much longer, and it could actually overload the search, and the search won't work. So those are 2 issues to look at, and let's look at how we can possibly try to resolve it. So, all right, so now we got looking down the slide. And again, here we have the problem. The table only answers in one direction, as I said before. To answer the question of the direction, you need to search 3 different fields. And I don't like the wording of this. I didn't write this, but the table is designed without recognizing we're dealing with 2 different classes. I'm actually going to get rid of this. Let me just drop that because it was a misnomer idea. All right, so don't worry about that. We have 2 different classes, but it's not classes like you think school classes. I'm going to get into what the classes are now. So let's go ahead. And again, this just really kind of quickly shows you how, what I already said. If I could sit there and quickly look and see that Greg Carter donated crayons and tissues. But if I want to look who donates it, I have to go across 3 different donations. And again, I'm just going to get rid of this for us. We don't need that. I don't like the wording of it. And okay. So let's go ahead to the next one. So this is what we want to say. This is where the classes is coming from, and I think it was just because everybody's thinking in kindergarten class, we think 2 different classes. We're thinking of actual physical classes, not classes of data, or data types, or groupings. So the idea is, if we can go up here, one of the simplest ways when dealing with data in a database is you want to, if you can, break it apart into tables are specific. So the tables will handle certain information. It's kind of like, think about, you go to your doctor. You have your general doctor, but if you have a heart problem, you go to a cardiologist. If you have a problem with your kidney, you go to a nephrologist. If you have other problems, foot problem, you go to a podiatrist. They're specialized. The same thing with data. We want to try to specialize the data. Okay, so one way to break this group up really simply is you break it into 2 tables: parents and donations. And so what we did here is we have a parent ID. And so you can quickly look across this table now and say, hey, crayons and tissues, 1, well, that's Greg. And I can say, who brought tissues? I can say 1 brought tissues, 2 brought tissues, and 3 brought tissues. I just have to search 1 column. And 1, 2, and 3, so that's Greg, Allison, and Juan. Okay? Uh, it's simpler. And the one thing I really, really want to stress is yes, you're saying this is not easier than just looking at the Excel file. No, it's not. For a human, it's not. But we're not trying to make this easier for a human. We're trying to make this easier for a machine or a database to read and to be able to write quickly to, and to not waste too much memory. So that's one of the things we want to think about is you got to start thinking not in the direction of what is it easier for a human to read, but what's simpler for a machine to sort through. Okay, and again, in these small databases, yes, it's really not any difference as far as the computer is concerned. But once you start putting this in orders of magnitude of millions of records, it becomes quickly, if your design is bad, you've got a problem. All right. Uh, and again, so this is we can just explaining again how we can, see what somebody provided. We can go both directions. I can say, what did Greg provide? 1, 2, those two things, and I can find out who's bringing crayons. Crayon 5 and crayon 1. So Greg and Anu are bringing crayons. Really simple to figure out, And again, this is just another provided tissues. Same thing. That's what I just explained earlier. So the slides kind of duplicating it. All right, so the big takeaways from this first example are don't let the existing form dictate your design. And it's so easy to do. Somebody gives you data or they give you a problem and they already kind of thought it through, and you're like, oh, I'll just, it just fits right into a table. You're good to go. But you really need to sit back, look at the data, think about all the different things that can be done with the data. And, I'm not trying to say you got to, look into the future, but kind of think about the future. What future uses might you have for the data with the database design? And as we get deeper into this, it'll all start to make more sense. Number 4 is really I think this is probably the most important statement here. Don't simply rush to load data in a table. Take time to think through your design. Another problem is repeated data. Now, again, in a small data set, it's hard to look at and see. But when you're talking millions and millions of records, you don't want you don't want to waste space on a database. You don't want to waste. This was really important when I was younger and databases were smaller and computers were not as powerful. But even now, you really want to try to avoid duplicated data because you're just eating up space. So here's an example here. We have an order table, and it's got an order number, and then you've got the person order, Greg Sherman, his address, and his phone. But look, he's in there 4 times, okay? So that's a lot of wasted space in the system. So what we need is we can create 2 tables. We have an order table, which will have our order number and the customer number associated with it. And we have a customer table. And now we see this Greg Sherman is customer 1. So every order 1, 2, 3, all order 1, 2, 3, 4 are all going to him. So we have it all on this one nice table right here. And this is what I mean by related tables or relational databases. This table here, order table, needs to relate to this table so it means something. So you have a customer ID. Well, what's this customer ID mean? Just like I'm sure there's another table here that would tell you what order number 2 control is. What is an order number 2? Is it bags of sand? What is it? We don't know. But that's what we mean by relational databases. This table has to relate to this table to get the information it needs. There's no other way it can know that George Sherman is customer 1 without relating to that table. And that's what you're seeing up here, these things called PK and FK. So PK and FK, that stands for primary key and foreign key. A primary key is a unique identifier of a row. So if I have these customer IDs and I start adding more customers down here, I'm going to give each customer their very own number. Just like you have I'm sure you have a student number. Everybody's American has a social security number. If you're coming over here with a green card, you have a tax ID number that allows you to work here, and that's a unique number to you. And it's the same thing here. So think about this like a serial or an ID number. And so when it's in the table, that's it. You can never repeat this number in this table. You can only have one 1 in this table. But notice we have a bunch of 1s in this table. The reason we can have all the 1s in this table is because in this table, it's the foreign key. Foreign key means it's a key that tells you I'm connecting to a primary key in another table. So while the order numbers here are all unique for the order numbers, the primary key, that's the foreign key in this list. The foreign key is related to this table. So you're going from 1 to 1. So that's why it's called a foreign key, because it's referencing another table, referencing a foreign table. So that's the information here. And again, this is all about not repeating data. And the final thing we're going to do is a lot of times, a lot of requests come that they want to get certain information. They want to report that, I want to know how many, students got below a C on certain tests and da-da. So at that point, it's really simple to try to build your database for building that single report or single output. But I really don't like that idea because your database can grow into so many different needs, and you really need to have a more robust, more flexible database design so that as other needs arise, you don't need to keep building a database for each need. You could just utilize this database for multiple needs. And you want to think about, this is a little graph put together here for this. And this is, again, this is very much access-based because we're saying inputs are forms and outputs are reports. And there's nothing can be farther from the truth and reality of this. Your input of your database can be anything. In Access, they use forms. In most of the world, it's an application. It's a front-end application. So if you have your front-end developers really do a lot of your input stuff. Think about every time you go to sign up for something on an app. That's what you're interacting with the database when you put your information in. Your output could be a report. Often is. Your output could be a video game. You walk around with your video game, you have, how many weapons or things do I have in my bag, for your. That's how it's kept. It tells you, it all sits in a database somewhere. So really, I don't like the simplicity of this because it indicates that this is all databases are used for, is input and popping out reports does not. God, databases are the basis of almost everything you use. The input and output could be a web page, could be a video game, could be anything you can think of. So, but the main point is I don't want you to sit there and think let's design a database based on just on the output report they're asking for. And here's an example. The university wants you to build a database to hold student grades and GPAs. They give you the following report as part of the requirements. What would go wrong if you built a table just like this? Well, a couple things. Number one, what happens next year if they offer a new class? How are you going to deal with that? If a student retakes a class, let's say Pete here didn't get a B plus there, let's say he got a D. And he's like, hey, I don't want that on my GPA, so I'm going to retake S202. There's no space here for a retake. And if your table can't handle relatively straightforward additional uses, it's flawed. You need to think about that. This will not work because if we add new classes, somebody needs a retake, that kind of thing, it doesn't work. This is way too stringently built. So basically, in summary, don't base your table design on a form. Think of table designs. Most time these tables only work in one direction. Always think of being able to retrieve data in both directions and think about other questions, not just the current data at hand. And don't base your table design on a report. Reports provide an after-the-fact view will most likely be limiting, and think about how much other information you might be needed to reduce the report and other things you can produce with the data you have. And Mark, thank you very much for watching this. The next lesson will be on the design process. The first couple lessons really are just kind of talks. After that, we start to get into the actual development and working with databases, which will be, I'm sure, for computer science students, much more interesting than just looking at charts and graphs. Again, thank you very much. I hope to see you again soon.